Hi guys, it's Tuesday morning, new day, and last night I was thinking about this graphics card. I often do this, and I suggest something to yourself if you're not clear, or maybe you are clear about something, especially if you're not sure. Go away, think about it, or maybe don't think about it, and possibly the next day you'll have some inspiration or some other idea, and that's what happens with me. It often happens. So I wake up early morning, 5, 6 in the morning, still dark, and things are in my head, and what was in my head this morning was this. It's not like I went to bed thinking about it. It kind of happens in the night. And this is what I suggest if you're not sure. Go away and think about stuff, guys. Don't bang your head against the wall or whatever. And what's happened with this, I'm pretty convinced, is when I started off and I found a low resistance here about 10 ohms, from then on I've been convinced, rightly or wrongly, I've either got a faulty GPU or faulty RAM because it's not easy to fix, and I'm thinking, well, that's just my luck, yeah, and that's what I've been convinced I've got. And I was measuring from either side of this coil 9 ohms on a DC multimeter, and you can't see any difference one side to the other. So I used a method we've used before where you had a short circuit. There's definitely a short circuit one side or the other, and we're using the ESR meter. It's effectively using the resistance of this coil, or so to say the inductance of this coil, which the ESR meter sees, to determine which side of the coil is a short. And that works. I mean, that's a good technique if there's a short. But here we don't have a short. We have like 10 ohms of resistance. And an ESR meter basically sends a 100 kilohertz tone through the components, yeah? So when you send it through a capacitor, it will actually see, I'm going to go through a capacitor here, and it will read a capacitor as a low resistance. I can get a contact on the capacitor, yeah, 1.06, yeah. So what I was doing is I was going this side of the coil and saying, let's get a good reading on it. Let's settle down, yeah, about 1.16. What I saw on that capacitor actually, because it's the same rail. And this side, I was seeing more. Well, I need to settle down about 1.4, 1.44, 1.5. Speed a little bit. I think the contacts on this are not the best, But anyway, I definitely have more this side, 1.33, than I have this side. Yeah, and I'm sort of saying, well, the low resistance is on this side. That's where the low resistance is. But if you measure across this coil, you see the coil itself's got a resistance of about 1.3. So if I'm seeing from this side about 1.1, yeah, I should see about 2.4 from the other side. So that's the 1.3 here, and then the 1.1 to ground. And I'm not. I'm just seeing this side is a little bit higher than this side. So I think what's fooling us here, or fooled me, is the fact there's a lot of capacitors to ground on this side, yeah, and there'll be some capacitors no doubt on the other side. And I think what I'm effectively seeing is a path to ground through capacitors on this side, and a path to ground through capacitors on that side. Obviously some's going through the coil, but that has a resistance of 1 point odd ohms, and I think that's what's jinxing it. The fact I'm not seeing the resistance of that plus the capacitance on the ESR meter. So that was the first thing that bothered me. If it was a short, you'd expect to find like maybe, almost zero this side, and then like if you go across the coil, it might be like 0.6, and from this side you'll see 0.6, and this side practically zero. That's where you're finding the short, and you've seen the resistance of that coil, and you know which side it is. So that's the first thing that bugged me. Second thing that's bugged me. At the end of the video yesterday, I thought, okay, let's just remove the low side FETs, because I'm looking at this. Well, I drew the circuit here, yeah. Let's get into view. I drew the circuit here, and I'm looking at this circuit, and I'm saying, okay, look, if we remove this FET and we remove this FET, we've effectively removed from this coil the path to ground. So there's no ground on the end of the coil anymore, yeah? And then we should be able to see where the low resistance is, and it didn't help. If anything, it's just slightly low on this side, and this side the same as before. And I thought, yeah, that's good. So the fault's on this side, and I was already convinced that's the problem, so that's it. But what I thought about this last night, I thought, Rich, you know there's another path to ground here. You're not thinking this through properly. And I'm going to show you where that path to ground is now, yeah? So let me just go to the screen capture, one moment. Here we go. So, we have, in fact it's still on the search from yesterday, IFPUDEUV7088. This is the controller chip on the other side of the graphics card that's got a hole in it. Yeah? And we can go to the PDF. And here it is, yeah? Go on, scroll up, there we go. A bit more, right. So, let me just get in a good position where you can see it nice on the screen there, yeah. So I'm saying this is your example circuit, yeah. And what I'm saying is, I know I've got a low resistance from here to ground, effectively, yeah. So, if I remove this one, then I've removed that path to ground. And if I remove this one, I've removed that path to ground. So the low resistance must be on the other side. If it's still there, it must be on the other side, the load. And that makes sense if you look at this. But it's wrong. Simplified application circuit. I know this chip has another connection to each of these coils, and it's called phase. And what it's there for is effectively so it can detect when one of these FETs is turned off and when the other one's turned on. And if we scroll down here, you'll actually notice on here you've got phase 2 and phase 1, yeah? And if we go further down, it'll tell us what phase are. Phase 2. Switch node for channel 2. This connects to the pin. Connect this pin to the source of the high side MOSFET and the drain of the low side. That is the junction between the two MOSFETs and the coil, yeah? And it's saying connect it to there. And if we look, there'll be a phase 1 somewhere as well, and it does the same thing. Phase 1, the same thing, yeah? And if we go even further down, there's an application circuit, and this is a not as simplified, and you can see quite clearly your top and your bottom MOSFETs and your coil, yeah, for each phase there and there, yeah? And then here, from this coil, goes to phase 1 on the chip, and from this coil goes to phase 2 on the chip. And we know this chip's got a hole in it. And what occurred to me last night is, hang on a sec, that 10 ohms could be from here. It could be in the chip, 10 ohms to ground. Because the chip's got ground on it, yeah? And it's got these phase 1 and phase 2 on it, and that's where we could be seeing effectively from one or both of these a resistance about 9-10 ohms to ground. That's why I haven't diagnosed the fault properly, or the possibility. So the only real way now, we've already removed that. So we know there's no path to ground here. That's what I did yesterday. We know there's no path to ground there because we've removed them. So the only way to prove now is it here, or is it on the GPU or the RAM, the 9 or 10 ohms? Is either to remove the chip or remove the coils. Yeah? So if we take the coil out, then we've broken the circuit from here to the chip. There's a little feedback coming in through here, which through a capacitor and then a 1.5 ohm resistor, and then through another 3.6k resistor to ground. And effectively, both of these would have to be short, and we know resistors don't tend to fail short; they tend to fail by going high resistance. If you didn't know that, you should watch what the tutorials I did on resistors, and then you would know that. So it's not very likely there's a problem there. So anywhere else, you know, is there a path to ground? Well, that's phase anyway, so no. These go to phase anyway, so no. So basically, I think the easiest way is either remove the chip or remove the coils, and I'm going to remove the coils. That's easy to do. So let's get the hot air and let's remove these two coils, and then 100% certain we'll know if the 9 or 10 ohms is here or if it's in the load, and that will prove it beyond all doubt. Okay, so hope you followed that. If you're having any problems, you know, following what I'm explaining, ask in the comments below, and I'll certainly, you know, go through it in more detail or even do another video for you if you need one. Okay, so that's that. Let's go back and have a look at the unit. So I'm going to take these two coils out. Yeah. It takes quite a bit of heat to do this, but it's fairly easy to do. But this time I am going to put a bit of Kapton tape around these resistors here, because I will need to get a lot of heat into here, and there's some very small components here. You can see them on the... Is the microscope working? Let's have a look. One moment. Yes, it is working. Okay, let's have a quick look. So this is where we were working yesterday. A bit of focus on that. This is where we remove the two FETs. And you can see there's some small components down here, just in there. There's one. There's this a bit bigger. I don't want to accidentally remove that. Everything else is clean. You can see we did a good job yesterday of removing this without dislodging anything. So it was a nice desolder job. But yeah, I want to just protect those. So let's get a bit of... that was the lid falling over as I bounced the thing onto the desolder. That was this falling over. Yeah, so let's do that. Let's put some Kapton tape on. Find my Kapton tape behind me. It's behind you. It's behind you. A bit of Kapton tape on here. Let's get these coils off. You like that? Huh. Still waiting for somebody to chastise me over that, but I'm still going to keep on doing it. Probably why nobody's chastised me, because you know I'm not going to take any notice. Okay. So we'll have to get a fair bit of heat into this to remove these coils. I've used the bigger tweezers, I think, on these. So have a little dig down in here. What do we have? Yeah, chunkier tweezers. Okay, let's do the job. So 450 again, maximum airflow. We don't want to stress the boards, so we're not going to get heat directly on these straight away. We're just going to get the general area warming up. This might actually help if I just balance the end of the cords slightly off here. So I'm reducing the conduction into this metal, yeah. Come over here. Start get some more heat into it now. Right, I've warmed it up a bit. I'm going to get the soldering iron and try get some leaded solder on either end of these as well now. I've got some warmth into it. Just one moment while the soldering iron gets hot. I'll take a few seconds. Let's finish. Let's get a bit of flux on them. This will help them to unsolder if we put some leaded solder at the end of them. Okay, this will be nice and warm now, so it should work quite well. This get on there. Yeah, nice blob of leaded solder on the end. This reduces the melting point, as you will know by now if you've been watching the videos. Okay, blobs of leaded solder on either end. Okay, back in with the hot air, and this time we'll just take them off. We should see the leaded solder melt actually, just as they're ready to desolder. Not yet. Desoldering inductor coils takes quite some heat, I'll tell you. But you can guarantee there's heavy ground planes and heavy power planes in the board here. Right, look, the leaded solder's melting, I can see that. Let's get heat right on the top of it now. This is why you need a good hot air, by the way. That one's off. And this one should come quite easily. There. Okay, they're off. So now we need to let that cool down, so I'll see you guys in a few minutes. Okay, so that's cool enough now to let's have a look. Still a bit warm, but you can touch it, it's fine. So what we want to have a look now is to see what's the resistance to ground either side of where these coils were, because this for certain will tell us which side the low resistance was. So the one we really want to know is the GPU and the RAM. Do we still have 9 ohms? No, we don't. I'd expected nearer to 100, but that isn't unreasonable, I think, for a RAM supply. What's on this side? Yeah, low. This one is a bit lower than the other one. What? Because they get into the different phases. So that's where the low resistance is. Obviously these were in parallel before, so I'll probably see if I might be able to get across the two of them, you'll see. Yeah, which now across both of them 11 ohms. So there's our low resistance. It's not the RAM. It's not the GPU. It's the only thing they're possibly connected to, it's this chip. So yeah, now we have something. Now we have a good possibility of a repair here. We know it's this chip because it's got a bloody hole in it. We don't need to mess around trying to find where it is. We know exactly where it is. Only question that leads to is why did it go bang? And I don't really know at this moment in time. Maybe let's just zoom down a little bit. Maybe somebody has some theories as to what caused this to go bang. Do you have a good focus there? That's pretty good, yeah. So yeah, maybe you got some theories as to what's caused this to go bang. There it is, look. What I would like to do is test the MOSFETs as well. Because basically a MOSFET, the gate should be completely insulated from the source and drain. So unless the MOSFET's got a short circuit, there's no path there for the current to flow. Let me just set the focus and I'll be back in a sec. Okay, so we've taken out the low side MOSFETs, which I have here. I'll get them under the microscope. And we have the high sides are still on the board. And I actually made a note on my diagram here of the part numbers that I can read on them. K0389 and K0392. And the 392s are the ones we've removed. So let's have a quick look, see if we can find a data sheet for these MOSFETs. Okay. What do we have? K0389. See if that's is actually a part number. Oh, obviously it's been searched for before. So it's an RJK0389. That's the full part number, yeah. Renesas is the maker. Yeah, this looks like the thing. So there it is. So you can see pin 1 is the gate, and then there's a tab underneath it. So 2, 3, 4 and 9. Yeah, so these 3 and that are all drain, and the other end is source. Yeah, that's that one. And probably the other ones that are the same pin out, I wouldn't be surprised. So let's see if we can actually test the ones we've taken off the board. We can see how it is. We can look underneath it and see which is a gate. It's the one pin on its own, yeah, and this little space here. So let's have a look and see what we actually have. Okay, let's go to the microscope, which is amazingly still working. So there's one of them. Here's the other one. Which, interestingly, doesn't look exactly like the datasheet did. Or does it? Yes, it does. It's just a bit grubby with flux on it. Let's get the other one. Here's the other one. Okay, so turn around. We got them both the same way around. There. It's funny because all these seem to be connected together, but you said one of them is the gate, which is interesting. But let's see what we can actually do, see if we can test this. It actually has a different layout than the whole thing we just looked at. Maybe that's the wrong datasheet for these, you know. But I'm pretty sure what you'll have is this will all be drain or source. 3 of these will be drain or source. The other one will be the gate. Let's see if we can prove that. I'll just get the instrument camera on and we can look at the meter at the same time. Let's just move a few things around. There it is. Let's get the test meter where we can see it, yeah? And I'm going to set it to diode mode on the meter. Okay. There you go. Find something to balance that up against. Find something to balance that up against, as you can still see the screen of it without the glare. I should do this stuff off camera. Okay, we can see it now. So if I get the test probes and put them together, 0, yeah? No. Let's look at these. I'm expecting it, really, one of these middle two will definitely be source, yeah, or drain. I'm not sure, whichever way around they are. So there you see like a diode junction, and the other way, turn that back over, little bugger, it moves out of view and turned upside down. Okay, so once again, so positive on here, we see the diode junction. The other way around, we're not seeing anything, yeah? Now, if I find the gate and put the positive meter lead on the gate, it'll be one of these two ends. I'm not sure which end. Try this end, yeah? No, that's still the diode junction. It must be the other end. Right, touch that to that, yeah? That should turn this FET on now, and now it should actually look like a short circuit. Possibly discharge it when I turn this upside down. Let's try again. Touch to that one. Get connection on it. Let me look down the microscope. Much easier for me. Okay, so yeah, this acts now like a short circuit. Yeah, until I touch the black one to the gate and switch it back off again. Should be now be switched off. Yeah, there's your diode junction off. Once again, red on there, switch it on, it should now have a short. Yeah, until we switch it off. So that's tested that, we know that's good. So the same with the other one. So this way you should see a diode. This way should be open. If we touch the red to the gate, yeah, this should now be a short. Should be switched on. Yeah, switch the black to the gate, it should be switched off again. Yeah, that's how you test FETs. So those two we can test. Now, can we test the other two in circuit? I don't know. The gate is now not connected to anything, so that same trick might actually work. I'd certainly want to test these two upper side MOSFETs. Let's go to the camera. And the reason I'd certainly want to test these two upper side MOSFETs is for the simple reason that I don't know why that chip's blown up. I just can't think of a good explanation for it. So let's see if it actually works in circuit. I've never tried this before, by the way. It's the first for me. So let's have a look. So across the MOSFET, 0. Another way I'm expecting to see the diode junction, I guess. No, I see zero either way. Let's try the other one. Okay, that doesn't seem to have the diode in, but fair enough, it's reading open circuit. Now let's try find the gate, which I'm guessing is going to be one of the end ones. Let's try this one first. Touch the gate. Nothing happens. Try the other one. No, so I can't test, either can't test them in the circuit or it doesn't work. I did wonder if it was possible to do once the driver chip has been disconnected, which it isn't. It's still there, by the way. Yeah, that's not going to work. It's not going to work because this is still acting as a low resistance. Let's take them off the board and let's see if they are good or bad. Okay, back to some hot air. I might put a bit of Kapton tape again on this one as soon as I've got it to hand. And I also want to kind of protect this capacitor from the heat as well, so I definitely will put some tape on here. It's worth trying that. I said I've never tried it before to see if you can do that in a circuit. If the gate was connected to nothing, maybe, possibly, you would. But again, it's something I've never actually done before. I'd have to say from the first experiment, no, you can't. Is the answer to the question. A bit more Captain. There's a little resistor or something down there. I certainly want to keep the heat out of the capacitor, for sure. I mean, otherwise I'd be tempted to actually desolder that capacitor. But no, I think we can get in now, and we can probably desolder these MOSFETs without too much drama. Okay, where's my little metal plate? I'm not going to bother trying to get leaded solder on them because there's a big tab underneath these things anyway. Okay, let's just set the focus for you. Okay, that should do. Tweezers, check. Hot air, check. Let's go for it. I hope you can understand the reason I'm checking these. It's because I have no understanding of why that chip has blown up, basically. I can't see any reason. I mean, sometimes things just fail, but I don't know. Seems a bit strange. If I can get these MOSFETs cheap, to be honest, I'll probably order some new high side and low side MOSFETs, even though they test okay, if they're not expensive. We can change the controller and the MOSFETs. That's probably very good practice, to be honest. I mean, if they're expensive devices, then you might think twice about it. But let's have a look, see how cheap these are. If we can get everything we need for about €10, I think I'll be happy just to change these as well. Better safe than sorry, so to speak. A bit of flux on these, actually. See if that'll help them. Although again, because the big tabs underneath, it probably doesn't help as much as you'd hope. Okay. Go back in again. There's nothing here, so we can just slide this one up off the board, actually. When it eventually gives it up. Come on. Starting to think a preheater would be good to use with this. Starting to worry about this capacitor. If it blows up, we can put another one in, but it'll certainly go with a pop if it does. That is proving remarkably difficult to unsolder. I'm now starting to think I do need the preheater. Give it just a little bit more. If we ain't going to give it up, I'm going to get the preheater on this. Eventually. Just as I was about to give up, it came off. Try this one. Oh. Sod. I probably lost a nearby SMD there. Probably knocked something out of the way. I can see, I think I've moved something in here. The whole thing just slid, it was very slippery. So in some of these pads you get a lot of surface tension under them and you can't bloody lift things up when you want to. Oh well, we can have a look, see what we've done to it. Right, let's let that cool down, let's see what we have. Okay, so here's our other two MOSFETs. You'll be wanting to see this again, I'm sure. Let's see if I just turn the camera a little bit. There you go. That's a bit easier. Set to diode mode again. Okay. There we have. So yeah, let's see what these do. Basically, we'll go for one of the middle two. Yeah, it's reading like a diode junction, yeah. Let's turn it around a little bit. If I'm looking down the microscope again, because I don't look so stupid when I do it this way. Okay, so that's like a diode junction. Okay, this reads like a diode junction both ways, fair enough. Let's see if we can find the gate. No, that's a diode junction, so try this end. Ah. Aha. Short circuit from the gate. That'd be a good reason for the chip to explode. Look at this one. Doesn't read anything across here. Short circuit from the gate. Okay. That's a good reason for doing that then, ain't it? Now we know why the chip's blown up. Now we know everything. Now we know everything that's happened here. And they're the high side, so the 12 volts would have gone straight into that chip when they blew up. Let's see what total mess we made when we unsoldered them, because I'm pretty sure I accidentally lifted or knocked some components out of the way. Let's see what we have. Yeah, I can see it, but it's still there. It's marked as D11. It's this component here, but I've just twisted it round. I haven't actually knocked it out of the way. Let's see if we just get some good focus onto the screen for you. I think that's focused. It says it's a diode, D11. So we should probably ought to see a diode junction on that, I'm guessing. Get into the microscope again. So we should see a diode junction one way on this, I'm hoping. Not that way. books on it. That reading short. Could be that I'm just. Yeah, that reads short as well. So we're gonna have to find out what that is. Probably the example circuit will help us with that. We need to order two. We need to order top side MOSFETs, and while we're at it, let's order bottom side. Let's see if we can get them. And we need to figure out what this should be. In fact, it's broken. It's actually broke. That might have actually just been damaged during the work I was doing. That might have been me. Okay, so best thing with that, I think, is for me to go on to one of the forums, probably Bad Caps, and ask anybody if they know what that diode should be. There, yeah. And that's, I think, about. I think it's a diode. It could be. It may actually no. I thought you said D. You know, that might be like a low value resistor. And hopefully, if we look on the example circuit and figure out where that is in circuit, that should possibly tell us what that component is supposed to be. But I'll still ask first if anybody got one of these and do they know what it is. If not, we'll get onto the data sheet, the example circuit, see if we can figure out what it is. Okay, so last thing with this then, we're going to order a controller chip. We know they were about €4 for a pack of 5 of them. We want to see if we can find some K0389s and K0392s. I think we've proved now without doubt why it blew up. So now, can we fix it? Okay, so let's have a look on AliExpress. Can we get the bits we need? If not, I'll go and see if somebody knows any equivalents for them. That's another possibility. Is either Google or ask if somebody knows an equivalent. So K0389. See if we got them. Yeah, plenty of them. 5 for €1.50 plus, so £2.50 with the shipping. Yeah, 5 of them. How about the other one? K0392. Same sort of price. In fact, they'll combine the shipping, so I'll probably save shipping. But let's say £2.30. So, yeah, all the bits we need to fix this are going to cost about €10 in total. I'm now seeing a reasonably good resistance on the RAM and on the GPU. Not saying it hasn't been damaged; it may well have been damaged, but you know, I think it's worth trying on this one. That's what I'll say. I think it's worth trying to see whether it is actually something we can fix. Okay, I think that's everything then, really. Apart from to zoom out and say, I'll put this on one side now. I'm going to do two things. One is to try to determine what that component is that got dislodged and broke. I think it might be a low value resistor. I'll probably do a little video in the meantime once I figure out what that is. Yeah. Second one is going to be to order the parts. We're down here in the Canary Islands, so that would normally take 4 weeks, something like that, maybe. So yeah, when the parts arrive, we'll be back on this and see if we can fix it. See you soon, guys. Guys, I said I'd do a little reprise on this graphics card once I clean it up a little bit. So I have cleaned it up. This is the component which we dislodged. I dislodged. It came from here. And it reads 0 ohms, like a 0 ohm resistor or a very low resistance resistor. And looking at it, this is the high side MOSFET. This is the other high side MOSFET. So the two channels are identical, just phase 1 and phase 2. And you can see that from this pad here goes to here. So this is where the resistor is. So one end's connecting to the gate of this phase, and then the other end appears to go down through the board here. to the controller, I would think. And this resistor seems just to be in series with from the controller to the gate. This is the other one, and this one just disappears straight down the board. This is the gate of the other one, so I don't see a same resistor here, and I'm guessing that is because it's on the other side of the board. But I'm guessing there's another resistor of the same value as this on the other side of the board. And if we can see what that is, then we can replace this one. That's the idea. So I'll get the data sheet up because we've got a good idea which pin it's going to go to. And let's have a look to see if we can find the other resistor and what it actually is. Okay, so we can see here is the controller chip, the one with the hole in it. And basically we know that the gates of the MOSFETs will go to this chip. It looks like they go via a resistor because I can see one on the other side. Hold on, I've got a phone call coming in. Okay, so what I've done is I've tagged a wire on to the other end of this resistor that's come off, that I think it's a resistor that reads 0 ohms. And I've actually, I'll show you on the overhead camera. It's easy to show you what I've done here. Got lines on it, strange. One moment. Oh, that's a bit better. I don't know what's causing those lines. Yeah, so what I've done is I've made a mess of the bench. I basically tagged this wire on here, and then I've wrapped it around here a few times. So I don't want to put any strain on that pad. It's quite easy when you're doing this sort of thing to actually rip a pad off the board. Yeah, so you want to be careful. But we need to do this to see effectively where that goes. I found it too hard to hold the probe this side and get on the other side to see where it goes. So that wire is just clipped to the black lead of the test meter, yeah, into the negative. And then I've got the other lead. And what I can do now, I had a look on the data sheet, and this chip, it's pin 1 and pin 18 that go to the gates. So I know this end of this resistor, it goes to the gate, the other end, so it must go to upper gate and lower gate pin on here. I'll show you on the data sheet in a minute. So, yeah, there it is. That's pin 18, pin 1 is, so pin 1 will go to the other one. Let me show you on the data sheet what I'm actually doing. Let's see. Data sheet. Okay. This is the data sheet, and we can see from the example circuit, which is down here, the typical application. Yeah, okay. We can see that the upper gate 1 goes to one of the high side MOSFETs, upper gate 2 to the other one, and these are the ones that are blown. They're on short circuit to the gate, so the 12 volts come down here into the gate, and that's what's blowing these chips up. Yeah, so blowing this chip up. In our case, we appear to have a low value resistor in this circuit, or maybe just a 0 ohm used as a link. So one of them goes to pin 1 and one of them goes to pin 18, and we know that goes to the gate. Yeah. Or in our case, we can see from the circuit board, the resistor goes to the gate, so the other side of the resistor must go to there. So here it is. So there's a dot on the chip, yeah? Pin 1 is by it, and then we go anti-clockwise, and pin 18 is up here. And I can see that from pin 18, I've got a connection to that resistor, that end of the missing resistor. So what I'm going to do is now, I'm going to tag my wire on the gate of the other upper side MOSFET and measure the resistance from there to pin 1, and that will tell me the resistance of that missing resistor. Well, it's not missing, I've got it, but it'll tell me if it really is 0 ohms or that component's faulty. I'm pretty sure it's a resistor. I mean, I don't know for certain, but it looks like a resistor. It's not marked on the board, it doesn't say this or that, so it's a bit hard to tell. The only thing I could possibly be with that with a diode, but I don't think so, but you know, who knows. Okay, so let's go back onto the microscope. Let's go to the overhead camera again. Okay, so what I need to do is now is focus this up for you. Okay, so you can see where I tagged the wire onto the end of the missing resistor. The other end, if it is a resistor, it goes to the gate of this. We can track, and we've seen that anyway. And we tracked it to there. So what we're going to do is we're going to take this wire off here now and stick it on the gate of the other MOSFET. And I want to see what the resistance is between there and pin 1 on the controller chip. This is on the basis that the two circuits, the two phases, are identical, which we have every reason to believe that is the case. So let's take our wire off this pad here. Okay. Let's get onto the gate of the other one. Okay. Let's stick it on there. Okay. So wire's on that gate now. Again, as you notice, I'm using this as a strain relief to keep this from moving. Yeah. I don't want to rip the pad off, and I've done it before. I've been there and done that before now. So let's just try to flick it over. I'm not going to light flat. I don't want to say don't put strain on that wire. I don't need to light flat. So this is the chip. Let's get the meter somewhere where you can see it. It'll do. It'll do. Right by the chip, but it'll do. Okay. So I'm balancing this with my fingers underneath. It's not lying flat against the desk. So once again, find the red probe, which is now fell between my legs. And let's go to the resistance, to pin 1 on this chip. Can I do this with that where you can see that? Yeah, I think so. Count the pins. This was 18. Pin 1's by the dot, whereas I'm sure it's over here. Yeah, it is. Yeah, that also reads extremely low resistance. So we can be pretty sure now our 0 ohm resistor, or whatever it is right. It's the same as the other channel. We've got the same resistance from the controller chip to the gate on both phases. Okay, so that's the last bit of the jigsaw. So resistor can go back on, I'm sure it was a resistor now. We need to change this chip. We need to change the two high side MOSFETs, which were short to the gate. We'll change the two low sides at the same time, and we'll cross our fingers and hope it hasn't damaged the GPU or the RAM. But you know now, there's only one way to find out. Okay guys, that was a little reprise. You've had that now, so let's wait now until we get some replacement parts for this. See you with this one in a few weeks, but I'll see you very soon with another video.